Okay, let's move on to the next question. So the Andes lawn is twice as much as the area of the Bethis lawn and 3 times as much as the area of the Carlos lawn. Okay, so there's some informations here, right? Well, at least we have 3 people. Let's digest it. A, B, C. Okay. Then we have the area. So the Andes lawn is twice as much as the Bethis and 3 times as Carlos. So it's x. Then we parameterize using the x. Okay. So this is the area. The Carlos lawnmower cuts half as fast as Beth's lawnmower, right? So Carlos is V, then Beth's is 2V, the speed, okay? And 1/3 as fast as Andes. It's 3V. So if they all start mow their lawn at the same time, who will finish first? Okay, it's just this is just the rate, the area, and the speed, right? So let's calculating about the time, right? So this 3x over 3v is x over v. So this is x over v is 2/3 of x over 2 is 3 over 4x over v. So this is a common one, right? It's a common thing. So that's B is first. Next. Okay, so Vic can beat Harold by 1/10 of the mile in a 2-mile race. Harold can beat Charlie by 1/5 of a mile in a 2-mile race. If Vic and Charlie, Vic race Charlie, how far ahead of how far the Vic can finish ahead of Charlie, right? So let's see. So in here, the only thing doesn't change is the length of the distance, right? So now let's set up equation, okay, and parameterize something. So we know the 2 equals, first is v beat h, right? 2 equals the v, the speed of the v, times the t, right? And over the same t0, right? The speed of the h can only travel 2 minus 1/10, right? Okay, so this equals to 19 over 10. Okay, now let's parameterize it. So let's see if the speed of v is m. Okay, then the speed of the Harold is 19 over 20 m. Right? Because Harold travels slower, right? Now let's set up another set of equation, okay? 1, 2, right? Another set of equation is the Harold can beat Charlie, right? Now let's see. The Harold speed times the T1, right? When Harold finished the 2 miles, the Charlie can only finish 2 minus the 1/5, right? So we know the Harold is traveled this faster, right? The speed. So we can calculating the Charlie speed, okay? It's 19 times 9 over 200 m. Okay, now we are going to see we have the speed parameterized. This is called the parameterized, okay? By m. So every one speed can be parameterized by a common things. This is very useful, okay, when you deal with the ratio. So now is the V and Charlie, right? So you know it takes the m times the t0 is equal to the 2, right? This is how fast the Vic can finish, okay? Then the next is to see how many miles the Charlie can travel over that period. So it's 19 times 9 over 200 m times t0, right? Is equal to 2 times the 19 times 9 over 200. So that's why you can see the distance, right? That the Vic can be Charlie is the 2 minus 2 times the 19 times 9 over 200, right? So you can calculate it's 29 over 100 miles. 42. Okay, so on an auto trip, the distance read from the instrument panel was 450 miles. So so the distance is 450 miles it travels, right? With the snow tire on the return trip over the same route, the reading is 440 miles. So find to the nearest hundredth of an inch the increase in radius of the wheels. Okay, the problem is like this. You can think, okay, the original radius is 15 inches. Okay, so basically the odometer working is counting how many cycles it's rolling, right? So it's the circumference of a fixed number. Okay, so we see the fixed number of the r equals the 15 inch. Okay, times the number of cycles. This number can be fractional. Okay, is equal to the distance, right? But once you have the chain, right? So the radius becomes bigger. Okay, so it takes less cycles for you to travel the same distance. Okay, so now let's see that we can calculate it. Okay, so we have the 450 miles. Okay, we have the 450 miles. Okay, divide by the 2 pi if we think is the r. Okay, so basically it's 450 miles divided by the new circumference is that we think how many cycles it travels, right? This is the number of cycles with the new wheel, right? And we think inside the odometer they think is the circumference is still the 2 pi times the 15 inches, right? So this end up get us the 440 miles. Okay, now we can calculate it. Okay, we can calculate the r here. So the r is equal to the 450 over the 440 times the 15. Okay, so it's equal to the 1 plus 1 over 44 times the 15. Okay, so now you can see that if the change of the radius is the 15 plus 15 over 44 minus the 15 is 15 over 44 inches. Next. So suppose y is jointly proportional to the 100 integers. Okay, the joint proportional means y equals k times the x1 times up to x100. Okay, you can also write in this way. So pi equal to 1 to 100 xi, okay? This just means the product. This symbol only means the product. So if Jerry triples 25 of xi's, and by what number can v multiply each of the rest of the numbers to leave y unchanged? So y also need to be k, right? Times 25, right? We triple the 25 numbers of xi, right? And we must do something else, right? We must do the ratio of something else with the rest of 75 datas, right? 75 datas. Then we can keep the product unchanged. Means this, right? So this equivalently means 3 to the 25 times the alpha to the 75 is equal to a constant 1, right? This equals, when we take a square root of the 25, means 3 times the alpha to the 3 is equal to 1. So now we can solve it. Well, 3 square root of 3. Okay. 44. So suppose x and y are inversely proportion. The inverse proportion means a constant. Okay. Means x times y equals to constant. Okay. So let's solve question A. So xp and yq are also inversely proportion. Then how much? Let's see. xp. Okay. xp times the yp is equal to k to the p, right? So you want the xp and the yq also equals a constant, right? From here, you can see p equals q. The b, xp and the yq are directly proportional. Okay, then how much? Okay, so x and yp, xp, yq need to be directly proportional. Means x equal to the a times y. Okay, this is called directly proportion. A times yq. So we can, starting from the basic, is xp times yp equals kp, right? Kp is a constant. Then we can solve as the xp is equal to the kp of the constant times the y negative p, right? So now you know xp also equal to a constant times y to the q. So now we know the q equals negative p. Okay, next. In an h-meter race, okay, Sunny is exactly d meters ahead of the Windy when Sunny finished the race. Okay, so that's in a h-meter race. Okay, when Sunny finished the h-meter, the Windy can finish only the h minus d meters. Okay, let's set up the first equation. Is the h equal to the Sunny speed times the t0, right? And in this case, h minus d equal to the Windy speed times the 0, right? The same thing, we can try to parameterize the speed. The Sunny speed is m, then the Windy speed is h minus d over h times m. Okay. Now the next one. Okay. So the next time they race, the Sunny spottily starting d meters behind the Windy, who is at the starting line. Okay. This means here is the starting line. Here is the starting line. Okay. So Windy is here, and the Sunny is d meters after here, after the starting line, right? So it asks you how many meters ahead is Sunny when Sunny finish. How many meters is Sunny when Sunny finish the second race? Okay, so on the second race, you can see the Sunny travels more distance, right? So Sunny travels h plus d distance, right? She still used the same speed of m and t1, right? We want to figure out over the t1, right? How many meters? How many meters does the windy travel? So now let's solve it. So t1 is equal to h plus d over the m, right? And the times the windy speed, right? So the distance of the windy move the second time is windy speed times t1 is equal to h minus d over h times h plus d over m, right? So it's equal to h squared minus d squared over h is h minus the d squared over h, right? So the Sunny travel, when Sunny finish the d plus the h, right? The windies finish this, h minus the d squared over h. This is where windy is. So Sunny still leading windy by the d squared over h.